Point 3 is looking at rational exponents. So one more time, what's rational again? Rational means anything that can be written as a fraction. So rational includes whole numbers as well and integers, but also anything else with a fraction part. So look, 1/2, 1/n, 1/3, stuff like that. So we're looking at any type of exponents, not just, we've done whole numbers and we've done integers. So rational means it can be fractions without a denominator of 1 now. So anything, so like 1/2. Let's look at the meaning of a rational or fractional exponent. When we look at this, if we are following the exponent laws, remember, always use the exponent laws first before you start doing reciprocal, etc. So if you're using the exponent laws, you're going to just add them together. So this will be 1/2 plus 1/2. Right? So your brain is thinking 1/2 plus 1/2, which is 1. 2 to the 1. Do I show the invisible one? No, I don't. I leave it invisible. Okay. The only number that follows this pattern is we've done radicals now. When you do a root 2 times a root 2, it equals 2. True? Root 2 times root 2 is 2. Root 4 is 2. So then they went, wait, does that mean that square root means 1/2? And they tested that theory, and yes, indeed it does. So that square root actually means 1/2. Then they said, in general, does that work for everything? Yes, it does. And we're going to now learn something called the nth root. The nth root. So it's not just square roots, third root, fourth root, fifth root. So how does a fifth root, etc., work? Well, it's going to work, and I'll show you in a minute. So we've got this one here. So instead of looking for 2, nth root means you're looking for n number of the roots. Now let's do, first of all, we're going to look at the notation, and then we're going to look at how to calculate it. So complete the following chart. This is going from exponential form to radical form. So this is exponential to radical form. Radical is, again, the symbol with the radical. If I give you 5 to the 1/2, that is the same thing as me saying square root of 5. Okay? I do not put an invisible 2. So that is invisible 2. Don't put a 2 there. We've never put a 2 here. You're leaving it invisible. So anytime there's no number, we're assuming it's a square root. We know this already. That is square root of 5. Okay. So now, if I want the third root, they went, okay, then that looks like this. Third root of 4. So that denominator here, tells you the root that it is. That tells you what the type of root. That's a little bit smaller in that little tick mark, right? So not that. So make sure it is not like this. Okay, it can't look like, if it looks like it's 3 times root 4, then you know 3 times root 4 is 3 times root 4. Like, that's totally different. It has to be a little bit smaller and a little bit tucked into that. Again, it's not neatness, it's accuracy, right? Like, it's just, I need to be able to read it properly. So not this. Backwards, if I have a little, yep.
Why do we put the 3 and not the 2?
Because it's 3 here. So see, this is the theory we have here. So it's, if it's 1 over n, that's the nth root. Oh. So if it's 2, then it's a square root, but we don't put it. If it's a 3 here, it matches here. It's the third root. Okay. So this guy here matches this here. So if I put the 5 here, it's going to be 7 to the 1 over 5. And you have to make sure, again, that this is not, it does not look like 7 1/5, because then, again, sorry, some people do this. I can't tell if that is 7 whole and 1/5 or 7 to the 1/5. So you, again, not neatness, accuracy. I have to be able to look and go, oh, she means exponent, right? They mean exponent. Okay, so not neatness, just accuracy. It has to go, can't go right beside. You can't say, but I know it's an exponent. I need to see that it's an exponent. So a little bit up in there. Here, what happens if there's 2 things happening? So this one and this, 2 things happening. So the bottom number is always going to be the root. The negative is sitting in front, minding its own business. So you just stick this in front. It's not part of the bracket, right? So it's not part of the root. It's not part of anything. Then you say this is the same thing as root 2 is the base, 7 is the bottom, so that 7 is going to go here. So the 7 goes there. Okay? The 5 is on the top. That is just regular 5, 2 to the power of 5. So I'm going to put the 5 here. I'm going to do this in purple, so 5. There. Okay. This is the same thing, so or, just give me one of the answers, but or, you could have written it this way. Still the 7 goes here. There's nothing you can do about that. But some people go, can I put the 5 outside? And yes, you can. You can say the whole thing is to the power of 5. So the top number is the regular old exponent. The bottom number, the denominator, is the part that goes in the radical. Yes. Oh, thank you, thank you. Negative. And the negative can either go, oh, it should go outside because it's not part of anything. Yes, so it should go outside. Thank you. So look, the 5 over 7 only applies to the 2. Does that make sense? Not the negative. The 7 in the denominator is always going to be the radical, and the 5 on the top will always be the regular exponent. Okay, so backwards. The radical is square root, so I know that the base is 5. Okay, base is 5. The root is a square root, which is an invisible 2, and the 3 is just regular. So we know that it's over 2, right? That's the invisible 2. And the top part here, the 3, is the regular exponent, so that's 3 over 2. All right, next one. We have, this time I have the whole thing and I'm grabbing it. Do you see the difference? Look at these two. This one, it's outside of no bracket. This one I want to grab the whole thing. So this is going to go inside the root. It's going to go in it. And this is different scenarios, right? This is not grabbing it. This one is grabbing it with the bracket. So then we've got in the root. So in the root is the negative 3, the whole thing. Because it's grabbing the whole thing, and the whole thing has the power of 5, 3. So those brackets like arms, grab the whole thing. I want the whole thing to have a third root here, so a little root there. And I want the whole thing to have a power of 5. So you have two choices. Either do this, grab the whole thing, 5. Make sure your root goes to the end, please, like that. Or I could do it this way and go, so it's negative 3. And then I'm going to say this is inside the root, so it's a 3. And I'm grabbing the whole thing and saying the whole thing is to the 5. So that's also acceptable, same. Just as long as the negative 3 is within and being affected by all the stuff. All right, last one. See how it's 1 over? 1 over. 1 over means reciprocal. Reciprocal is the negative exponent. So I want you to learn how to do this one. We're going to do 3 is my base. Okay, 3 is the base. I know it's squared, and I know it's third root. So squared, we go on the top. The third root goes on the bottom. That makes sense? So the third root goes on the bottom, and the squared goes on the top. But the whole thing is 1 over. The whole thing is the reciprocal. If the whole thing is the reciprocal, the way that I can put reciprocal is this. So that's what I was talking about that last example, is that if you can understand that it's under and it becomes a negative, it does come in handy sometimes. So this whole thing is to the negative. Or, okay, I'd like to write it this way instead. I go 3, the 2 is on the top, it's over 3, and then instead of putting the whole thing to the negative 1, I just stick the negative here, on the top or the middle. Okay, so I'll say on the top or middle. You can go in the middle of the fraction or on the top. Is that okay? So you don't have to have a bracket. I don't really like that because it adds another bracket and then I have to do more simplifying, so I usually put it there. You can also put it in the middle of the fraction. Do you want me to put that? So or it would be 3, 2, it's over 3, and then you can put the negative here in the middle, not in the denominator. Right, so all same? Okay, that I have not even calculated anything. We're just changing form. So in that case, that's just being able to change back and forth between the different forms. Haven't started calculating. So let's, in example 2 here, we're going to start to calculate it. So what is the third root of 8? The third root of 8 is this. Okay, like that. I'm looking for groups of 3. Groups of 3. So square root, you're looking for groups of 2. I know 8 is 2 times 2 times 2. I have 3 groups of 2. When I third root it, I'm taking it out and getting just 2 back. So that's my brain going, oh, because 8 is 2 times 2 times 2? Yes. Just like if I said square root of 4. Square root of 4 is 2 times 2. And that's why it equals 2, because it's 2 groups of 2. Now I'm looking for groups of 3. Is that okay? So looking for groups of 3. Then I'm going to do fourth roots. I'm going to be looking for groups of 4, fifth roots, etc. So third root of negative 8. What's the third root of negative 8? I'm looking for 3 numbers that multiply themselves to get to 8, negative 8. So I know right away it's a negative. 3 negatives makes a negative. So it has to be a negative. What number times itself gets itself to 8? We just did it. 2 times 2 times 2. So you go negative 2. So it works like a square root, but we're looking for groups of 3. Now I'm looking for a group of 5. What number times itself 5 times will get you to 243? So I know I said no calculators, right? But you are allowed to use calculators. You shouldn't need them. This one sometimes you might I need to figure out what that is. But it is actually 3, right? Something times itself 5 times gets big pretty fast, but if you check it, it's going to be negative 3. Negative 3 times negative 3 times negative 3. And we know it's negative. You can just try 3. So 3 times 3 times 3 times 3, 5 times is 243. Yeah.
How would you input that in the calculator?
Yeah, so I'll show you on the calculator. Again, you shouldn't be asking me because you don't want your calculator, right?
Yeah.
Yeah.
Just curious.
Okay, so yes, I'll show you on your calculator. So you're going to go third, so press 3 first. Then you're going to look for this button here that has a little X in the little crook of it. Right, so shift this. So third root, sorry, and I want fifth root. So 5, then shift this. So that little X button with the X there, every calculator has it somewhere on there, scientific, and it's going to be negative 243. And that'll get you a negative 3 back. Okay? Again, you shouldn't need it. Okay? But as a check, you're like, oh, I hope I did that right. 3 times 3 times 3 times 3. You can do it backwards and go 3 to the power of 5. Yes, it's 243. Okay? Some of the numbers are bigger, so that's the only time where you might be like, I just want to double check that I've got the right idea and right number. I'm okay, but other than that, you shouldn't be using your calculator. Okay, so it's a quick double check to look, yes, 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 I got that one. Sorry, question?